So this is part of the masterclass series that I have been taking for the students, right? Okay. And many of you might have attended my previous sessions as well. And today it's going to be a very interesting session on continuity and differentiability. And today, in this entire session, you'll solve lots of problems which have come in IIT JEE, and you yourself will be able to solve it. A few things before I start. Okay, guys. So today, since it is a webinar, a masterclass where there are hundreds of students, so I'll not be able to see all your questions which you are posting there. Okay. So what I will do towards the end of the session, I will give you my email ID and my WhatsApp number so that you can post your doubts, okay, to me either on email or WhatsApp. One. Second thing that you will get is you'll get the recording of this session. You'll get the recording of this session on your email IDs, which you guys use to register for this session. Okay, cool. So don't worry, try to understand as much as you can, but towards the end, you will get the recording of the entire session. Okay, ready? Okay, so before I start, let me ask you one question which will help me refine this session for you. Just let me know about this. Which class or the grade that you guys study in? Okay, good. So this is the kind of breakup that I was expecting. So majority of the students are either in 12th or they have done 12th, that is droppers. Okay? And around 25% are either 11th or 10th and below. So I have kept this session in such a way that first of all, since it is continuity and derivability, so it is actually for the 12th graders. But since I'll be doing it in a very different way, so 11th graders and probably 10th and below might be able to appreciate it as well. Okay? Chalo, cool. So this is who you guys are. All right. So, acha, one more thing. So this is what I just again to share the result. Around other than 25%, all are 12th and above. Cool. So you will be able to appreciate concepts a lot. Another thing that I want to ask you, how many of you have already attended one of my previous sessions before? All right, interesting. So for 60%, it's their first one, and 17% are already regular students of Vedantu, and 24% have already attended one of my previous sessions. Very good. Okay. So probably you might have attended my graph sessions. You will be able to appreciate this session a lot today. Okay, let me close it now. So 16% are regular ones, 25% have attended my session earlier, and 60% are new. So hi to all the new ones. Okay. And for the new ones, I'll briefly introduce myself. So I am Pulkit. I did my BTech from IIT in 2005. Okay. After that, I founded Laksh Institute in 2006. So I, along with my friends, we created Laksh Institute. Uh, Through that, I've taught tens of thousands of kids till now, and many of them have got top 10 ranks. In fact, last year, All India Rank 1, Sarvesh, had studied at Laksh Institute, which I had started. But then I realized that, uh, if the teachers like me or the great teachers in the country, there are many out there, if they have to reach out to all the students in the country, then I think the best way is technology. And that is the reason why after that, after starting Laksh Institute, then I started Vedantu, where we are using technology, we are building technology to reach out to students like you sitting in all parts of the country. And tomorrow, after learning and getting into IITs and other colleges, you are the future of technology, and you will be creating the best technology to take education anywhere, right? So that's what inspires me. That's why I teach kids like you, right? Chalo. On that note, this is what we're going to do today. Okay. Today, we will learn differentiability and continuity in a very, very different way. In today's session, you will solve IIT problems, but you might not need any equation or expression or calculations to solve the IIT problems. Today, you will be solving problems graphically. Okay? So in today's session, you learn a lot of new things about graphs. If you know those things, it will be better, but I'll try to give those concepts to you. and you'll realize that so many problems of IIT, of mains and advanced level, you will be able to solve without writing any expression or equation. So a quick revision and some concept building here. Guys, imagine this is the graph of y is equal to fx. So imagine I have plotted a graph of y equal to fx. I have created a graph which will help you understand all aspects of continuity and all aspects of differentiability. Okay. So guys, remember, so wherever a function is not defined, see, look at it, look here, look at this point C. At C, f of C does not exist, right? F of C is not defined. Hey, there is a hole. What we call it? We call it hole in the graph. If there is a hole in the graph, then the function is not continuous. है ना? What is a continuous function? Imagine you're sliding. Imagine you're sliding on a slide. Had there been a hole, you would have fallen down, right? So that slide is not a continuous slide. Look at this portion of the graph. This is continuous. No break, no hole, continuous. Look at this portion of the graph. This is discontinuous. Where? At x equal to c, because there is a hole. Look at this point. Look at d. When x is equal to d, look what happened. The function has broken. The function has broken. Okay, what happened? To the left of d and to the right of d, the function is taking different values. I hope all of you have learned limits somewhat. Okay, because I'm not going to teach the limits today. All right. एक second, guys. Hope are you able to see my screen? Just let me. Oh, I'm really sorry. My screen was paused. I'm really sorry. So let me again start. Yeah. So what I was saying. So this is the graph that we will be learning today. Okay. And based on that, we'll be solving lots of problems. So now look here. So this is the hole in the graph here. Wherever there is a hole in the graph, the function is discontinuous there. Okay. And wherever the function breaks, see the function broke here. It was nicely going like this, got a break in between, and then shifted somewhere else. So wherever there is a break in the function, there also the function is discontinuous. I hope all of you know this, right? Cool. Because today we'll be applying these concepts. So the wherever function breaks, it is discontinuous. Here also function is discontinuous because there is a hole. So at E and C, there is a difference. At C, function was not defined at all. At E, the function is defined. The value of the function is this, where there is this orange point, right? But still, it is moved away from this point. Had this orange point been here, the function would be continuous. But what happened? This point shifted somewhere else, creating a hole in the function. And wherever there is a hole, function is discontinuous. Okay. And if you have learned limits earlier, then I'll quickly revise the limits also. See here, the left hand side limit approaches this value and the right hand side limit approaches this point. So in this particular case, your left hand limit is not equal to right hand limit, or there is a gap, discontinuous. So function is discontinuous at D. Here, look at this. Here, if you look at the limit, the left hand side limit and the right hand side limit, they both are approaching the same point. So here a left hand limit and right hand limit are same, but that is not equal to the value of the function. The value of the function is this, which is not equal to the value of the limit. So guys, in today's session, understanding of limits definitely is needed. Okay, cool. So what are the points where function is discontinuous? Here it is discontinuous. Here it is discontinuous. At C it is discontinuous. At D it is discontinuous. And at E it is discontinuous. And look at this F. F, what happens? At F, x is equal to F, the function is not defined. Okay? The graph is approaching this vertical line, but it will never touch this vertical line. So at x is equal to f, along this line the graph is broken. So here also the function is discontinuous. So at x is equal to c, d, e and f, the function is discontinuous. Now wherever the function is discontinuous, obviously in those points function is also not differentiable. Always note, I hope you know it, but again revising, wherever function is discontinuous, their function is not differentiable as well. Okay, so this is the stuff which again I expect, this is the NCRT level, basic level theory which you should know. I'll be building on top of it today. Now comes one very important point here. Look at this point. If you look at this point, if I magnify it, the graph looks like this. If you look at this point, you'll realize there is a sharp corner. There is a sharp corner at this point. And wherever there is a sharp corner at that point, okay, at any point, if the graph has a sharp corner, then please remember the graph is not differentiable there. Graph is not differentiable there. Or in other words, there is no tangent that you can define on that point. If you want to understand, I'll quickly explain. See, look at this is a sharp corner. You can say this line is a tangent. You can say this line is also a tangent. You can say this line is also a tangent. You can say this line is also a tangent. You can say this line is also a tangent. Right? So actually, if it is a sharp corner, there are infinite possibilities of a line touching the graph at one point. And that is the definition of tangent. Since I cannot define any one particular tangent to the graph, okay? So there is no particular slope of the tangent that I can define. And what is the slope of the tangent to a graph? It is its differentiation, which you guys know. So wherever there is a sharp corner on the graph, in simple words, remember the function will not be differentiable. Okay. So before I go to the IITJ problems, again I'm revising. Wherever there is a hole in the graph or wherever the function breaks, okay, the graph is discontinuous there. Wherever graph is discontinuous, it is also not differentiable there. In addition to that, wherever there is a sharp corner on the graph, the function is not differentiable there. Cool? I hope you guys know till here. Okay? Let me just get a hang of it. Okay? Just let me know if you guys understand these concepts till here. Because I'll be using these concepts, right? So 11th graders might face some issue, but I think till now 84%, 85% students know these concepts. Very good. So I can easily use them. Others try to understand. Okay? But some things will be new for you. So all of you have responded. So 85% students understand this. Cool. It will help you. Now let's build ahead. Now let's try to solve some IITJ problems today. Look at this problem. So this problem came in IIT in 1998, and after that such concepts have repeated multiple times. Okay? So before I get into this question, okay, I want to explain you something which is very, very important. Just read this question once, then I want to explain a very, very, very important concept to you, which will help you solve the problem. So basically, it is a very interesting definition of function. It says function is the minimum of x or x square for every real number x. ये क्या है? What does it mean? Before that, let's try to understand a very important concept. सुनना इसको ध्यान से. If I ask you which of these is greater, what will be your answer? If I ask you which of these x or x square or x cube or x4 is greater, What will be your answer? Yes, so majority of you will answer that, you know what, x ki power 4 will be greater than x ki power 3 will be greater than x square will be greater than x. Acha, let's take an example. Let's take x equal to 2. Let's take x is equal to 2. Guys, understand this, because this is based on what the previous ITJ equation was. Okay? So let's take example of 2 ki power 4, 2 ki power 3, 2 square and 2, which is greater? Absolutely no doubt. This is the sign. 16, 8, 4, 2. But the entire story completely changes if I take x is equal to half. And that is where the trick lies. If you take x ki power half ki power 4, half ki power 3, half ki power 2, and half, in this, suddenly you'll realize what happens. The inequality changes. Now half is greater than, which is like 0.5, is greater than 1 by 4, which is 0.25, which is greater than 1 by 8, which is 0.125, and so on, right? Higher the denominator, lower the value. All of you know this. Higher the denominator, lower the value. So if I take x is equal to half, the inequality completely changes. So now this brings me to the conclusion. Please guys note down in your notebooks if you want to. Always remember this, but under the condition this. If the value of x is a fraction, if value of x lies between 0 and 1, remember, lower the power, higher the value. Lower the power, higher the value. But if x is greater than 1, higher the power, higher the value. Extremely important. Now, if you know this, then you suddenly know the graph as well. Now, I will tell you how you know the graph of all these functions. ठीक है, देखना ध्यान से. See, I'm plotting the graphs of y is equal to x, y is equal to x square, and y is equal to x cube. Look at these graphs very carefully. Okay? Just look at this portion of the graph when x is positive. This graph when x is positive, okay? To avoid confusion. What you realize here is that between 0 and 1, okay? Lower the power, higher the graph. X ka graph is greater than x square ka graph, greater than x cube ka graph. Because between 0 and 1, x is higher, then x square, then x cube. But when you go to the right of 1, when you go to the x greater than 1, then higher the power, higher the graph. X cube, x square, x cube, x square, x. But between 0 and 7, it is opposite. X square, x cube. Very important, guys. Okay? It's very important. So let me summarize it for you. And that will bring me to this problem again. Okay? Let's come back to this problem again. Dekho, what did I tell you? Let me summarize. If this is my coordinate axis, if I plot the graph of y is equal to x, let me plot only in the positive side of x, okay, to avoid confusion. I'll explain the rest. Then let me plot the graph of x square. ठीक है, x square का ग्राफ otherwise कैसा होता है? It's an even graph. This is y is equal to x square. ठीक है, the way it is in the positive side of x, it is exactly like in the negative side of x. Then let me plot the graph of x cube. This red graph is y is equal to x cube. It is odd graph. The way it is in the positive side of x, it is exactly opposite to that here. Why? Because at x is equal to 1, if x cube ka value is 1, then at x is equal to minus 1, x cube ka value will be minus 1. So the way it is in the first quadrant, it is exactly like that in the third quadrant. Symmetrical in opposite quadrants. X square power even symmetrical in the first and second quadrant. But the important thing for us was which graph is higher. So y equal to x is higher. Let me simply write x. Guys, I'm devoting time here because I will show you next 2-3 problems exactly based on that. Then x square and then x cube. But at 1 all are equal. At 1 x square, x and x cube all are equal at 1. All of them have value 1. And when we go higher than that, then x cube is higher, then x square, and then x. So if you know this, if you understand this, okay, now I will give you my problem. Now the question is the minimum value of x in x square. So let me explain that. So let me come to the problem now. The function is h of x is equal to minimum of x comma x square. It means whatever is minimum, whatever is minimum between x and x square, that is equal to h of x. Okay, now अब देखते हैं graphically. Now let's again plot the graph. Same graphs I'm plotting again. So let me plot the graph of again. This is y is equal to x, and the black graph was y is equal to x square. Now we'll learn how to solve it graphically, okay? And it's verbal question. This is y equal to x square, and the green one is y is equal to x. Now, guys, listen to me very, very, very carefully, okay? Now I am moving from here to here. I am moving from left hand side and going to right hand side. And I will always think between the two graphs, which is minimum. Minimum matlab which is below, the one which is below is the minimum. So listen to me very carefully. When I move from here to here, which graph is lower? Which graph is lower? This graph is lower. So between minus infinity to 0, between black graph and green graph, between the green graph and the black graph, which graph is lower? Which graph is lower is minimum, which I'm marking in red. This one. Now between 0 to 1, between 0 to 1, green or black, which one is lower? This one is lower. And after 1, which one is lower? This one is lower. That's it. You have the graph. The shaded portion, its graph, the shaded portion, okay, this shaded portion is the graph of the given function hx. That's it. What do you need to do? Plot its graph, which you have learned just now. Then keep picking up the graph which is lower at any given x. Okay. Now this suddenly tells me this. Dekho. So pink graph is x square. This blue graph is y equal to x. Then this shaded portion is minimum of x and x square. If you remove the other portion, your graph actually looks like this. Okay? Now my question is, guys, now if you read the question, if you knew the graph, which is this, then can you tell me where the function is continuous and where differentiable? Is there a hole anywhere in the function? Does the function break anywhere? No. It is completely continuous. If an ant keeps moving on this, it will not fall anywhere. So function is continuous everywhere. Okay? Is it differentiable everywhere? No. Look at this. If you look at these 2 points, you see a sharp corner like this, sharp corner like this, right? Since you see the sharp corners, hence at these 2 points, the function is not differentiable. It's a sharp corner. Function is not differentiable at all x. Okay? So hx is not differentiable at two values of x. Which are those values? X is equal to 0 and x is equal to 1. Got it? Now, third question. H dash x equal to 1. Very simple. Again, let me explain you. Now, your function ka definition is y is equal to x here. Here it is y is equal to x square, and here it is y is equal to x. So actually you can write your h of x as, listen to me very carefully again, for x less than 1, for x less than 0, sorry, it is y is equal to x for x less than 0. It behaves like x square for x lies between 0 to 1, and it behaves like x again for x greater than 1. It is always very simple to differentiate this. Guys, always remember, if you know the function, its differentiation finding is very simple. Just differentiate these individual functions. What is the differentiation of x? 1. What is the differentiation of x square? 2x. What is the differentiation of x? 1. So you see now, if somebody asks you what is the differentiation of the function for all x greater than 1, ठीक है, this symbol means for all, ठीक है. So what is the differentiation of the function for all x greater than 1? You can see this is the function for x greater than 1. Your function is this, and its differentiation is y dash x or h dash x means कितना हो जाएगा 1. So its differentiation is 1. That's it. This is also true. So answer is A, C and D. Did you guys follow? Could you guys understand? Okay, I devoted a lot of time on this question. Why? Because next 2-3 problems will be exact replica of this. Okay, so let me know if you guys understood or not. I'll explain the same thing in the other questions as well. After this, I'll give you problems which you will solve yourself after understanding this. Okay, very good. 85% of you got it. Very nice. For the rest 15%, I'll repeat it again and again. So a lot of time devotion to one problem, but the rest will become very simple. So let me close it. Very good. So 83% of you got it. Now solve this. IIT 2006. Exactly same problem, exactly same concept. Do it. Quickly make the graphs. You know the graph of y is equal to 1. So basically these are the three graphs you will be plotting. Y is equal to 1. Make its graph. Y is equal to x square and y is equal to x cube. Plot the three graphs and then keep picking the lowest graph at any given x. Keep picking the lowest graph. ठीक है? Do it. I'll run the problem in next 15-20 seconds. Till the time you do it on your own. Okay, noted. Should I run the poll? Let's see how many of you actually can get it. 1 x square x cube. Let's see if anybody could get it or not. 1, 2, Guys, the options will be lost. I mean, options will not be visible once I run the poll. Okay. So I hope you have read the options carefully. Okay, running it. Let's see if anybody can get it or not. All right. So the problem is the options were marked A, B, C, D. Actually, the option should have been marked differently because if it is a multiple correct option, है ना? कोई बात नहीं. Anyways, just see, just check your answers. Okay, let me close it. But probably I'll not be able to give a right assessment because see, majority say A, C. Majority of people have said. Let's see. देखो, see how fast I will do it. I will first of all do what? I'll plot the graph. Which all graphs will I plot? सबसे पहले y is equal to 1, which is obvious graph. Y is equal to 1, constant graph. Y is equal to 1. Then let me plot y is equal to x square. है ना? So y is equal to x square. Again, we know this y is equal to x square. Now let me plot the graph of y is equal to x cube. Remember, x cube will be lower and then higher. है ना? Sort of here lower, after that higher, intersecting at 1, and then it will go like this. So this is y is equal to x cube, the red one. Now we have to see the lowermost graph, the lower graph, right? So everywhere let's pick up the lower minimum. This one is lower. After that, between the black, the green, the red is the lowest. Then after that, again the red is the lowest. After that, the green one is the lowest. Agree? है ना? Could you appreciate this? Again, see carefully. Lower. The between black, green, red. Which one is lower? Anywhere. If you come from here, if you are coming from minus infinity to 0, you realize that red is the lowest graph or x cube is the lowest graph. Okay. After that, between green, black, red, again red is the lowest one because between 0 to 1, we know that x cube is lowest, then x square, and this is 1. Okay. And after that, red, black, green, the green one is the lowest. So actually your graph looks like this. Now if I just take out the shaded portion, your graph will look like this. It was x cube ka graph, आराम से आया, it went till here. After that, the graph was this. So this is your f of x actually, which behaves like y is equal to x cube till 1, and after that behaves like y is equal to 1. Now guys, the answer is fx is continuous everywhere. Of course it is continuous everywhere. Is it breaking anywhere? No, it's not breaking anywhere. It is continuous, which most of you marked. Is it continuous and differential everywhere? No, because we see a sharp corner. Here it is a sharp corner. So definitely it is not differentiable. It is not differentiable at x equal to 1. Fx is not differentiable at 2 points. No, it is differential. If you look, this is a smooth graph. The entire graph of x cube is smooth. So till 1, from minus infinity to 1, the graph is completely smooth. So it is differentiable everywhere. And after 1, it is differentiable everywhere, again smooth. It's just one point where it is not differentiable. So it is just one point where it is not differentiable, which is x is equal to 1. Cool? Okay? Wanna do one more problem like that? Let's do one more problem like that. Okay? Hope you are getting it. Let's do this one. Let's see. It was a sub It was a sub part of a problem which came in IIT, so I gave it to you. But here I'm going to tell you one more. I'm going to tell you one more important concept. So before you start this problem, let me teach you one concept. Note, guys, note it down. I'm going to teach you, if you know the graph of f of x, then how to plot the graph of, if you know the graph of f of x, then how to plot the graph of y is equal to mod of fx. Okay? It's very simple, guys. So let me give you a simple sa example. Let me plot a random graph like this. Imagine this is the graph of y is equal to fx. Okay? So whenever you want to plot the graph of mod of fx, what does this mod do? Okay? Remember mod of x क्या होता है? Mod of x is always positive, which all of you know. So when you take a mod of anything, what happens? That entire thing becomes positive. So for example, mod of 2 is 2 and mod of minus 2 is also 2. So even if you give a negative number inside the mod, it will become positive. With the same logic, guys, note very carefully. Whenever you plot the graph of y equal to fx and you want to plot the graph of mod of fx, what will happen? Wherever the graph was negative, it will come up. It will become positive. It will sort of come up like this. Exactly. The way it was below, sort of fold it up. Fold it up. Similarly, here the graph will be like this. So now this graph. So if I plot it again, so the graph of y is equal to mod, the mod of fx will look like this portion will remain as it is. Then the portion will come up. The portion was already up. This portion already also came up. This was the graph. So if this point was say A, B, C, D, this is how the graph will be. A, B, C, D. And this is the graph of y is equal to mod of fx. So guys, what will happen? Whenever you take a mod of a function, all the negative portions of the graph, they will just jump up. A sort of mirror image with respect to x-axis. With respect to x-axis. Got it? If this concept is clear, now please plot the graph of y is equal to mod of x cube. Plot the graph of y is equal to mod of x cube. How will this be? Y is equal to mod of x cube. The graph will be, see, let me first plot the graph of x cube. The x cube graph is like this. So if I plot the graph of mod of x cube, what will happen? This portion will jump up. The portion which was negative, which is below x-axis, will jump up. So a graph of y equal to mod of x cube will look like this. See, this portion as it is, and this portion which jumps up, it will be like this. This is the graph of y is equal to mod of x cube. Got it? Clear? Now, if you look at this function, okay, it is, if you look at this function, it is a smooth graph. It is a smooth graph. It is a smooth graph. Okay, y equal to mod of x cube. So since it is a smooth graph, it is differentiable everywhere. It is continuous. Yeah, it is differentiable everywhere. Rest, no option is true. Continuous but not differentiable at x equal to 0. No. At x equal to 0, it is differentiable. If I want to make a tangent, yes, there will be a tangent and its slope will be 0. So it is differentiable at x equal to 0 as well, because there is no sharp corner. So, and it is also a continuous function. So your answer is A, differentiable everywhere. Got it? Okay. So this is If you want to do it algebraically, this is the algebraic way of doing it. What did I do? You know now, if you want to do mod of x, it is x for x greater than equal to 0 minus x for x less than 0. All of you know this. Mod opens with a negative sign when whatever that is written inside the mod is negative. Right? So mod of x cube, mod will open with a positive sign if whatever that is written inside the mod is positive. So when x is positive, x cube is positive, hence mod opens with a plus sign. But if x is negative, then x cube is negative. Hence mod opens with a negative sign. So actually the portion of the graph is, this portion of the graph is x cube, whereas this portion of the graph is minus x cube. Got it? But graphically we could already do it. And if you want to differentiate it, no problem. If you want to do it algebraically, you can check. Just differentiate the function. X cube का differentiation 3x square and minus x cube का differentiation minus 3x square for x greater than 0, x less than 0. Hence, left hand derivative and right hand derivative both are equal to 0. When x is greater than 0, then f dash 0 is 0. When x is less than 0, then f dash 0 is also 0. Okay? But we could see, you no need to do it like that. You can do it graphically as well. Cool? So this was an important concept that I wanted to teach. Then let's move to this. In fact, let me take some very interesting problems. Let's take this. Do this. Use the concept which I just taught to solve this problem graphically. Read it. Again, IIT problem. Prashanti, I just saw your message. Don't worry. Just keep noting in your notebook. Okay? You will get the replay of it. Okay? Guys, you will get a replay of it. So just keep scribbling in your notebook. Okay? You will get the entire session as a replay. Don't worry. पढ़ा? Sin x का ग्राफ सबको पता है, right? All of you know the graph of sin x? This is the graph of sin x. The question is verbal. The hint is the question is verbal. If you can visualize it graphically. Now, first, so this is my hint देता हूं. This is y equal to sin x. Now think about the graph of y is equal to mod of sin x. What will happen? Once you have done that, then visualize the graph of y is equal to mod sin x plus 1. If you have attended my previous sessions on graph, you will know the transformation. The graph will shift up by 1. But don't worry, do it. Now let me run the poll. I hope you have done it. Yet again, the problem is the polls that I'm going to run will have A, B, C, D, but multiple correct won't work. So don't worry. Anyways, you do it in your notebooks. Do it all of you. Okay? I'll explain. Because again, running the poll will not make any sense. I'm sorry for that. देखा? अब मैं explain करता हूं. देखो. What will happen when you do y is equal to mod sin x? What will happen? All these portions of the graph will have jumped up. So how will your graph look like? Your graph will look like 0 to pi, pi say 2 pi, 2 pi say 3 pi, minus pi, whatever. What happened? This portion of the graph had jumped up. ठीक है ना? Sorry. The negative portion of the graph have jumped up. Yes. So this is the graph of y is equal to mod sin x. ठीक है? Now, when you add a plus 1 to the graph, what happens? the entire graph shifts up. When you add a +1, whenever to a function, when you add a value 1, what will happen? Think like this, entire graph will shift up. The entire graph, if this is x-axis, ठीक है ना, so क्या होगा? This entire graph will shift up. This is y is equal to 1. ठीक है? So nothing, no complication. Just this graph will now jump up like this. ठीक है? So this is the graph of y is equal to mod sin x plus 1. That's it. As simple as that. So mod sin x में क्या हुआ? The negative portion came up. Upon adding a +1, what happened? The entire graph shifted up along y-axis. ठीक है? This is simple graph transformation. ठीक है? Now, can you tell the answer directly? Very simple. Continuous. Of course, it is continuous. It's not breaking anywhere. So it is continuous everywhere. Of course, no. Differentiable at x is equal to 0. No. You see, there are so many sharp corners. Sharp corner, sharp corner, sharp corner, sharp corner, everywhere. How many sharp corners will be there? The sine ka graph keeps going, right? So there are infinite sharp corners. So answer is yes. It is not differentiable at infinite number of points. And actually you can tell those points are x is equal to n pi, because these points are 0, pi, 2 pi, 3 pi. At all the multiples of pi, the function will not be differentiable because there is a sharp corner. This is what I just said. So these are the points of sharp corner. ठीक है ना? Simple problem. So if you knew these concepts of graph, such problems which take quite a good number of marks in the paper are just verbal to solve. And as I'm giving you so many problems, you will realize there are so many problems in IT based on these kind of concepts. ठीक है? Cool. So I hope you could get this. I'll give you lots of more problems. ठीक है? I'll take this session till around 10:15. Okay. So I think all of you got it. Very nice. So let me now make it a bit more trickier. So 96% of you got it. Very nice. Now let me make this problem a bit trickier. Let's move ahead. Let me give you some more different problems. Yeah, let's look at this one. Let me explain this to you, and then I'll give you a problem based on this exact same thing which came in IIT. Now I'm going to teach you, you learned this, right? Mod of fx. Now I'm going to teach you f of mod x. Now what happens when we do f of mod x? Okay, now focus on what I'm going to say very, very carefully. So what happened if this was a graph? If this was a graph, your graph became this one if you did mod of fx. Agree? Your green graph became, if your green graph was fx, this portion jumped up to become mod fx. This is clear. But now see this very, very carefully. Imagine there was a graph like this. Imagine there was a graph like this. Okay. And maybe it was like this. Y is equal to fx. Now, whenever you do y is equal to f of mod x, remember, whatever that was happening in the positive side of x-axis will now also happen in the negative side of x-axis. Why? Because f of 2, देखो, even if you put x is equal to 2 and x is equal to -2, both will give the same value of the function, which is f of 2. If you put x is equal to 2, it is f of 2. If you put x is equal to -2, it will still behave like 2. So whatever that is happening in the positive side of x-axis, exactly replicate the same graph on the negative side. So What will happen when I want to plot f of mod x? Just forget about this negative side ka graph. Just make a mirror image of this one. So actually the graph will look like this. Got it? So this red graph, this entire red graph, the shaded portion is actually the graph of what? F of mod x. So what did I just say? I'll repeat again. Forget about the original graph. Original graph का negative portion को remove the, what you need to do, remove graph of fx which was in negative side of x-axis. Remove this. Then second step, step 1. Step 2, ठीक है, mirror image of fx in positive side of x, ठीक है, take that mirror image to negative side of x-axis as well. Okay, remove this graph and take a mirror image of this. Now let's come back to this problem. I'll explain this problem to you. What do? We plot this graph separately and we will plot this graph separately. Okay? And then we'll visualize this and visualize this separately and the problem becomes verbal. Very simple. देखो, मैं explain करता हूँ. First of all, let me plot the graph of f of x. Let me plot the graph of f of x. ठीक है? तो देखो, when x is less than 0, look at this very carefully, okay? When x is less than 0, then the graph is x minus 3. For less than 0, the graph is x minus 3, straight line ka graph. All of you know? When x is equal to 0, the graph tends to minus 3. Yes. So y equal to x minus 3 ka graph. But when x is greater than 0, then the graph is of x square minus 3x plus 2, a quadratic graph. Right? A quadratic graph को plot करने का there are multiple ways, but the most effective way is this. Remember, the vertex of a quadratic graph ax square plus bx plus c is always minus b by 2a comma minus d by 4a, where d is b square minus 4ac. This is the classical way of plotting the graph of a quadratic graph, x square minus 3x plus 2. So actually if you find its vertex will come out to be minus b by 2a, will give you, I think, 3 by 2. And if you find minus d by 4, I think you will get minus 1 by 4. So you know this point is 3 by 2, that is 1.5 comma minus 1 by 4. This is how the graph will be. Other way to look at it is, you can factorize it and its roots are 2 and 1. So 1 and 2. So the quadratic graph will be like this. Okay? So for x greater than 0, it is a quadratic graph like this. Now, once we have plotted the graph of f of x, what have you plotted? F of x. Now let's plot mod of fx. Remember, what will happen in mod of fx? Everywhere where the graph was negative will come up. This portion of the graph goes up and becomes this. This point becomes 3. This portion, what I'm doing mod of fx. This portion goes up, becomes this. Right? This portion also jumps up. So net graph becomes this, tick, tick, this. This is the graph of mod of fx. Got it? Clear? Now, let's plot f of mod x. What happens? I told you, erase the graph which is in the negative side of x-axis. Erase the graph. What is the original graph? F of x. This is the original graph. Just erase this portion of the graph. Rub it. Hata do. And just replicate, take a mirror image of this graph on the negative side of x-axis as well. So this becomes a graph of f of mod x. What did I do? Erase the negative portion of the graph in the original graph and took a mirror image of this one here. You have f of mod x, you have mod of fx. All you need to do is see where individually these are discontinuous or non-differentiable. Okay? To answer the question. Got it? See, it is discontinuous. It is discontinuous at x is equal to 0. You see a break here? Okay? Hence, it is non-differentiable. Non-differentiable at x is equal to 0. Why? Because the graph is broken. X is equal to 1, sharp corner. X is equal to 2, sharp corner. This is continuous everywhere, but it is non-differentiable. It is non-differentiable at 2, sharp corner. Just combine the two, you have the answer. That's it. So the question was to comment on f mod of fx plus f of mod x ka differentiability or continuity. Just do them separately and combine the answers. So this net function is discontinuous at 0. Net function is discontinuous at 0. Your answer is discontinuous at x is equal to 0 and non-differentiable 0, 1, 2, 2. Net x is equal to 0, 1 and 2. That's it. That is your answer. Such problems come at advanced level as well in JEE. Okay? But these questions are verbal. Cool. All you need to think about is sharp corner, broken graph. And all you need to learn is how to plot the graph. End of the story. Cool? Okay? So this is a problem in IIT, which let me skip. Let me give you one interesting problem. Let's do this. 2005 problem, simple one. Let f of x is equal to mod of mod x minus 1. Quickly make its graph and tell me the answer. Quick. Do it. The hint is do it in 3 steps. First, plot the graph of x minus 1, which all of you know. Then plot the graph of f of mod x. When you do f of mod x, wherever you see x gets replaced by mod x. Then plot the graph of, this is the trick. Let's see if you guys can do it or not. After that, I'll give you a problem which came in advanced. That's it. You have learned a lot of new things. Okay, but try to do it. It will take some time, so I'm just trying to buy some time with you guys. X minus 1 का graph, you know, right? Y is equal to mx plus c, तो सबको पता है. Slope is, in this case, slope is 1 and y-intercept is minus 1. So the graph, of course, will be y-intercept minus 1, slope 1. So this is your graph. This is the graph of y is equal to x minus 1. Remember, f of mod x means wherever you see x gets replaced by mod x. है ना? So if this is your fx, then this one, the red graph, will be your mod x minus 1. What will you do? Remove the negative portion of the graph and shift this to the, take a mirror image of this portion here as well, and then taking a mod, take all negative points up. I'll run a poll for this. Very interesting. And see so many problems in IIT. Bhar ke problems. Every year you will see lots of problems like this on IIT. So super important and super fast. I'm running the poll, okay? Not bad actually. So 48% of your correct till now. Almost 50%, not bad. Last 10 seconds. Okay, so let me close it now. 46% of you are correct. Why? अभी देखो quickly कर लेते हैं. That's so simple. So ये क्या होगा? In this what will happen? In fact, I must have done it to save time. Yeah, here it is. So you plotted the graph of, first you plotted the graph of y is equal to x minus 1. So this is our fx. Fx is x minus 1. Then we plotted the graph of f of mod x. What happens in f of mod x? We erase this portion of the graph and we take a mirror image of the right hand side portion of the graph. Right hand side matlab the positive x axis wala graph. This portion of the graph, you take a mirror image of it. Okay, so this becomes our graph, which is the graph f of mod x. Now we went from here. Now we are going from here to here. And now what we are doing? Now we are taking a mod. Now we are taking mod of f of mod x. So this graph, this is f of mod x. Now you put a mod outside of it. So what will happen? All the negative portions or below x-axis will jump up. So this portion jumps up and comes up to 1. बस यार हो गया तो फंडू है. So this is 1. By symmetry, this is also minus 1. So this is 1. This is minus 1. You have the answer. Simple. All you need to see is the sharp corners. So this is a sharp corner. This is a sharp corner. This is a sharp corner. At 0, this is x is equal to 0, x is equal to minus 1, x is equal to 1. Got it? See how simple these are at IITJ level. Okay? Let me give you a problem. I hope you got it right. Let me give you an IIT advanced problem. Wait, there are lots of problems which I have. Yeah, let's do this. So this problem came in IIT advanced and you realize this is super duper simple now. Look, read it. Take some time to read it. IIT advanced ka problem, they look very scary. They unnecessarily look very scary. But if you read them calmly in a composed way, they are very simple. Aram se dekho. Take your time. We have done maximum and the minimum wala thing, right? It's simple application of that. So read it aram se. The question is about plotting this graph and plotting this graph. That is it. Just plot these two graphs, end of the story. And after that, the question is verbal. Whenever it says minimum, take the lower graph. And whenever it takes maximum, take the upper graph. So for x greater than 0, take the lower graph between the two. For x less than 0, take the upper graph between the two. That's it. See if you guys can do it or not. I'll run the poll for it. Let's see how many of you can do it. अच्छा, by the way, एक चीज ध्यान रखना. So if you know the graph of y is equal to x square, one graph I'll tell. If you know the graph of y is equal to x square, then remember when you add a number, the graph shifts up. The graph shifts up. इसे कहते हैं vertical transformation. So this is the graph of y is equal to original graph plus 1. ठीक है ना? It has shifted up by 1. Cool. And similarly, you can plot this graph as well. So plot this graph, then take max between this and this. Guys, keep noting down in your notebook because once I run the poll, it will go away. So max between fx and gx, higher graph for x less than 0 and a lower graph for x greater than 0. Then find out the sharp points. That is it, as simple as that. So I'm running it, okay? 5, 4, 3, 2, 1. Let's see. Okay. Let's see. 70% of you responded. Very nice. So at least you guys can attempt, right? That matters a lot. So 12th graders and droppers, guys, this is the approach to learn limits, continuity and differentiability. Graphical way. Please learn all chapters graphically. That's what IIT is about. Okay? So let me close it. So guys, see, this is what you guys say. So 40% of you say B and majority of others of you say A and D. Okay, let's look at option B. Is it correct? Simple graphs. Let me plot it. यहीं पे बना देता हूँ फटाफट. So first of all, x square plus 1. So x square plus 1 is shifted up by 1. So this is y is equal to x square ka graph. All of you know plus 1 has shifted to 1. This point is 1. Then y is equal to mod x. So all of you know the graph of mod x again. So this is the graph of mod x. Right? This is the graph of mod x. Absolute function of x. Now if I plot its graph plus 1. So it will be like this. Okay. Now guys, here is the doubt which most of you have. This, remember, is the graph of between -1 to 1 or between 0 to 1. Which graph will be higher? Y equal to x will be higher. We just read. And y equal to x square will be lower. But after 1, x square will be higher and x will be lower. The same concept. See, the same concept again got repeated in the IIT advanced problem. Clear? Okay? So please be very careful about it. Okay na? So once you know this, once you know which is higher, which is lower, okay, then all you need to do is identify the graph which is, see, for x less than 0, I want the max or the higher graph. So higher graph, here a higher graph. Then this is the higher graph. Then after x greater than 0, I want the lower graph. Acha, so here a lower graph. That's it. So if you take it out, your graph actually will look like this. See, this is how your graph will look like. Let me plot it separately. पहले तो आता है ऐसे. First it comes like this. ठीक है? After that, it goes like this. After that, it goes like this. And after that, it goes like this. ठीक है? So this is where the function is changing here, here, here. So this is the straight line. So this is x square plus 1. This is minus x, right? Because f y equal to mod x is y equal to x and y equal to minus x. This portion of the graph is minus x. This is x square and this portion which is a straight line. So this is a straight line, okay? Yes, straight line. This is y equal to x. Sorry, everywhere it is plus 1. Everywhere there is a plus 1. Cool. That's it. Now see where is the function differentiable. The number of points where hx is not differentiable. The points of contention are this, this, and this. Here the pakke se there is a sharp corner. Look at this point. If I magnify it, it will look like this. Straight line, then a curve. So there is definitely a sharp corner here. Okay? Here, if there is a doubt, it's very simple. Differentiate this and differentiate this. Okay? Its differentiation is 2x and its differentiation is minus 1. So yes, there is a sharp corner here as well because the slope is minus 2 minus 1. At x is equal to minus 1, the slope is minus 2, slope is minus 1 here. So in simple words, there is a sharp corner. So if I magnify it, it will look like this. A sharp corner here as well. Okay? And a sharp corner here as well. How many sharp corners? 3. So answer is the number of points where hx is not differentiable is 1, 2 and cool. Got it? So what are the sharp corners? Again, I'll repeat. There is a sharp corner here. There is a sharp corner here. And there is a sharp corner here. Why? A curve, a straight line. A curve, a straight line. A straight line, a curve. That's it. As simple as that. Okay? And you can solve ITJ problem like that. Very simple. All you needed to do was knew the graph. Cool. So did you guys understand it? So now you can solve many such problems. So what did we learn today? 94% of you got it. Very nice. So I had many more problems of ITJ, all based on this. But today I am taking only these ones still here. Okay, very nice. Thank you very much. See, 94% of you got it. Very nice. Okay. So today what we learned, again, let me summarize it for you. The things which we learned today and which are super important for IIT are the concept of the max or the minimum of two functions, fx, gx. Again, very popular variety of problems. Okay. You learned how to plot the graph of f of mod x. You learned how to plot the graph of mod of fx. Similarly, other things that you need to learn, which I'll take sometime later, is greatest integer function of fx, f of greatest integer function of x. All these are very popular with IIT. Also, you learned today the graphs of how are these graphs compared. X, x square, x cube, x ki power 4 and so on. And finally, the usage of all these in solving the problems of continuity and differentiability. And trust me guys, majority of the problems in IIT will be based on such concepts which are super graphical in nature. Okay? So cool. So this is about it. So just tell me a few things. So by the way, I'll give you my email ID and phone number in a while. Okay? Just let me know one thing before I move ahead. Okay? Cool. So 91% of you, 92% of you learned something awesome. And 7% have some doubt. Don't worry, you'll get the replay in your email IDs. All right. After a couple of hours, the replay will have reached your email IDs. So don't worry. Just revise them once again. Okay. Chalo, very nice. All of you, 96% of you responded. So this is what you guys say. Awesome. Thank you very much. So now, a lot of you also ask me about, how learning on Vedantu happens. So guys, this is exactly how learning on Vedantu happens. But yeah, there is a slight difference. In our regular courses, though I could not take your doubt in the session, but in regular courses, it's very interactive. The students continuously ask doubts. We keep discussing in the chat, and at times we keep unmuting the students as well. So that is how the learning on Vedantu happens in our regular sessions under courses. So what all courses do we have? We have a 2-year course for +1 students. We have a 1-year extensive ITJ course for the +2 students, and there is a 1-year very intensive course for dropper students as well. Okay? And guys, this is the approach that we'll follow. We will go through the fundamentals and reach till JEE advanced level, and we will learn a lot of visualization and graphical techniques as well. And by the way, all the teachers who are teaching on Vedantu are the ones who have taught all these students historically. For example, I founded Laksh Institute from where all these students came, got the ranks in IIT, right? And all the material that these students used to learn, the assignments, the tests, the tutorials is exactly the same material that we give you in our courses on Vedantu. Okay, so teachers like me, say for example, Hari sir from IIT Roorkee has taught so many top rankers, Arvind Kalia sir from IIT Delhi, and there are many such IITian teachers who will be taking classes on Vedantu. Okay, and the most interesting thing is, you know what? All sessions get recorded and will be available for you throughout for entire 2 years or 1 year or whatever duration you're preparing for. Okay. Also, the study material that you get, okay, is exactly the same which all the toppers historically have been using, right? So you get theory material, assignments, graded exercises, detailed tests, very fine-tuned tests of each chapter level, then phase test, then entire test series as well, which are simulated IIT JEE tests. And this is super important. All the students who are learning on Vedantu in our courses, they become part of the WhatsApp groups where the teachers and all the students are there to discuss doubts 24/7 all the time. Okay. So it's amazing to see students asking doubts at 1 in the night and other students or teachers answering them. And all the handwritten notes, for example, whatever that I wrote on the board in our regular courses, all these things become available to you as PDF, downloadable PDF. Okay. So guys, these are the course links if somebody is interested. Okay. So you can note them down. So if you're 10th moving to 11th student, this is the course link, and similarly this and this. And this is my email ID in case you want to ask me anything related to today's session or otherwise. And this is my WhatsApp number. You can WhatsApp me as well. Okay, if you have any query. Cool? Okay. And by the way, how the courses work on Vedantu? Basically, this is how the courses work. First, there is a trial of 1 week. Okay. After trial, if you really see that there is value being added to you, then you take the course. Otherwise, you can take the whatever amount that you have paid for trial, you can take a refund of it. Either you take a refund or you move ahead to the course. Okay. So there is a registration fee for 1 week trial, which typically is 1,000 rupees. But in these links, the registration fee is 499 rupees. So you can register for the trial, the ones who are attending my session, at 499 rupees, which is refundable. So you can try out how the learning on Vedantu is for a week. If you like it, you can continue. If you don't like it, if you don't see the value being added, you can take a refund. So these are the course links. So today there is on registration, there is a 50% discount going on today. So I really suggest that you guys should definitely try it out because it's amazing. You can learn from the comfort of your homes The classes are at like 9 p.m. and 7 p.m. in the night. So rest of the day you can utilize for your self studies. Okay. So every day, for example, 2 hour session every day, very peaceful. Every day you learn from, for example, 9 to 11 or 7 to 9. That's it. Two classes per subject. Okay. You get replay of everything and learn from the best of the teachers in the country, right? And you get all the material that you need to crack IIT at advanced level. Okay, cool. And by the way, the courses, for example, if you take a 2 year course offline, typically, the institutes charge upwards of 2 lakh rupees for 2 years. If you go to places like Quota, you end up spending like 4 or 5 lakh rupees of staying there and stuff. But at Vedantu, it's like one third the price. Why? Because there is no unnecessary infrastructure that we need, and we don't pass on that infrastructure and random costs on to the students. So that's the power of technology. That's disruption. Okay? So these are the course pages where this offer is going on today. You can go to the course page and see the details. Okay? These are the links. And you can email me or WhatsApp me. But yeah, guys, whatever, take course, don't take course, whatever, please ensure that you change the way you learn from equations and expressions to visualization, graphical way. That's the way to crack IT. That is the only difference I see between the ones who crack IT and the ones who do not. ठीक है चलो, hope you enjoyed what you learned today. All the very best. Be in touch and keep working and studying really hard. These years are the most important years, and the return of your hard work that you will get in these couple of years is phenomenal. Never ever in your life will the return of your hard work will be so high that you will get in these years. ठीक है चलो, bye bye, good night.